like two data sets, like two different data sets? What is like an example of that?
Well, what I mean is it could be sort of like, okay, so if you have a bimodal distribution, you might have like two separate, you might be talking about all people or something like that. And you might have one group within that set that exhibits one characteristic and another group that exhibits another characteristic. So for instance, if you were looking at the heights of all Americans, you would probably expect to see, or even like all adult Americans or something, you would expect to see that you expect that to be basically bimodal, wouldn't you? You'd probably expect to see a little gap where it would kind of go down, but there would be two humps. One would be like around the average height for men, and the other would be around the average height for women. Does that make sense? So it's like,
Yeah, that makes sense.
you have like two sets within a larger set is the essence of what causes that to occur. And if you did all people, like all US citizens, you would probably see something that would be, not just bimodal, but multimodal. Because kids always have these like growth spurts at certain ages. So you would probably see lots of humps in the data if you were doing like height data or something like that. Does that make sense, Madeline?
Yeah, it does.
All right. What else? I also wanted to point out, I kind of alluded to this in the lecture. The next homework I'm going to assign will probably be from chapter 7. The stuff I'm talking about right now actually is closer to the beginning of Olowski-Dean. This is like, this data analysis stuff is near the beginning. It's more intuitive. I'm probably not going to assign any homework from it, but if you're just familiar with the kinds of things I'm doing in the lecture itself, that's all I really care about. I just want you to have a working knowledge base that will kind of support what we do later on. So there's not going to be any homework from these couple lectures, but I'll move into chapter 7 next week, and I will assign homework for that. Hope that makes sense. All right, what else? Why does sample variance, okay, here's Ryan, using the chat window. Why does sample variance use the sample mean and not the sample median? Well, that's a good question. Mainly because the population variance, right? Do you guys remember the population variance? What do you compare all the data points to in the whole population? What do you compare it against? What do you measure deviation from? Mu. You measure it with respect to mu itself. So that's why you use the thing that you think is really going to be close to mu, the mean for the whole population. Does that make sense? You just put that into the formula and you compare it against the sample mean. And again, the reason you use the sample mean in there is because you don't know what the population mean is. And you just compare all of your individual data values against the sample mean, get those sum of squared differences, divide by n-1. And the reason you divide by n-1, again, is because your samples are going to tend not to have outliers in there. And the outliers are the things that really tend to drive the variance larger, because those are hugely removed from the overall mean usually. So that's why you divide by 1 less than the sample, because that kind of bumps that number up a little bit. But Ryan, just to kind of circle back to your question, the reason you compare it to the sample mean is because you were comparing the population one against the sample mean or the population mean. And I guess from the beginning, we could have compared everything to the median. But we would have had to agree to do that from the beginning. And the mathematical community, in their statistical wisdom, decided they were going to compare stuff against the mean and not the median from the very beginning. Does that make sense, Ryan? All right, what else? What else? What else? Well, I hope things have been making sense. Again, don't hesitate to reach out individually. I try to respond pretty quick to emails and whatnot. So just stay in touch, keep asking questions. Thank you for coming and asking questions. I think that's beneficial for everyone. So you guys are doing some good work on behalf of your comrades. So thanks for coming. If nobody else has any questions, I guess we could call it a day. And don't forget, Friday's Good Friday, so we're not going to have class. I won't post a lecture until next Monday. Okay? I think I'm going to sign out if you guys are all right.
Thank you.